Hello and welcome back to Programming with Adam, and in this video we will be looking again at LeetCode problems. So the next one on the list is remove duplicates from a sorted array. So it looks like this. So I will just give you a couple of ideas. So maybe not in here, maybe in here. So right now I just set up something that doesn't really do anything. Just return the list, right? See, so returns the list and doesn't change it. And like the next. So one idea is to count, is to shift the numbers to the left if they are not a duplicate. So that will be something like if you have 1, 1, 4, 4, 6. What you will be doing, you will be, while you're looking at one that doesn't, 1 is okay, the first, so I equals to 0. Let's call it n. Well, there are no duplicates, so you do nothing. Do nothing. Then for I equals to 1. Well, now we notice that since it's sorted, we can figure out if it's a duplicate by comparing to the next one. So if the neighbor in the if the previous is the same, we have a duplicate. Okay, so record this. So maybe like d equals to 1, we have a duplicate. Now for I equals to 2, if the previous is okay, so for the next one, the previous is not the same, so no duplicate. So record it. So shift it, right? So at this point we will shift it, right? So we're shifting it how much? Well, just shifted by 1, right? Because we only had 1 duplicate, so we're just shifting it. Okay, and then we are looking now at entry 3. If it's so that's this one here. No, this one here. So if the previous is the same, we have a duplicate. So yeah, that's correct. So now D is 2, right? So we have a second duplicate. So the first duplicate, the first one was the 1, the second one is a 4. So D is 2. Record this. And finally, for I equals to 4, That's not a. If it is not previously the same, so 6 is certainly not the same as 4, so it's not a duplicate, and we record this by shifting it. Right? So how much? Well, we shift it by 2, and then so it goes into this position. So that's how and that's basically the result, and then return. We'll be returning basically the last number we just the index of the last one we put in, right? So where do we put it in? We put it in n of I minus the number of duplicates, right? So that was so at this point we had n of 4 minus 2. So that was n of 2. We set that to be equal to 6, right? So, but that's exactly gives us the length. So the length is is 2 plus 1, right? So I minus d plus 1. Okay, so however, I will not implement this idea. I will just implement another one. Tier 2 is simply convert n to a set and override n to a set and then a list and then add override and return length. So that will be the idea I will be using. So that maybe that's idea 2. So I think maybe that's not intended, but so we take nums and we override it. So we take the list of set of nums, and then we simply return the length of nums. Okay. So let's just try. Nums didn't really change, huh? So we do. So maybe we have to specify. Yeah, okay. So we couldn't just override, because if we just set an equality, that will not work. But then if we take evaluation from yeah, so that should be the fastest possible way to do it. So I'm just trying to implement that. So So I'm not, yeah. So let's run the code. Okay, and submit. Okay, so that actually gave a wrong answer. So the problem is that when we turn it to set and then into list, it might actually mess up the order. So we do have to sort it. So nonce sort. Yeah, let's try again. Okay, so we got a 99.7% faster than anything else, and I will be saying I am satisfied with that. So we will just leave it at that.